Hello friends, I hope you are doing good. In this video lecture I will be talking about isomerism. This video lecture can be helpful for college, school students, even BSc level, masters, MPhil or PhD level students. This is a very basic topic of stereochemistry. Again, it's a branch of organic chemistry. You should know how compounds arrange themselves into the spaces, or what is their arrangement, why compounds show isomerism. By the way, this is one of the reasons why organic compounds found in millions, because of their isomerism. What I mean by this is that one compound can exist in number of different forms. That's called isomerism. So let's define the isomerism. So the word iso means the same and mer means molecules. So it can be defined as molecules that have same molecular formula but have a different arrangement of the atoms in space. That's what causes them to make isomerism. If you talk about classification of isomerism, so isomerism can be classified into two types, two big classes: structural isomerism and stereoisomerism. Now we will first discuss the structural isomerism and then we will later discuss the stereoisomerism. So the structural isomerism is further divided into 5 different types. Number 1, chain isomerism, positional isomerism, functional isomerism, metamerism, and tautomerism. Let's discuss the chain isomerism. Chain isomerism is a type of structural isomerism in which two compounds differ because of their chain length. See, these two compounds have same molecular formula C4H10, C4H10, but if you look at their structural arrangement, they are different because there is a change in their chains. So this is a linear 4 carbon chain, but this one is a branched. So this one is linear and this one is branched. So that's the difference between these two molecules, and these two have same molecular formula, same molecular weight, but they are two isomers. What kind of isomers they are? They are chain isomers. So there exists a chain isomerism between these two isomers. Okay, let's discuss another type of isomerism, that is positional isomerism, in which there is a change at the position of a functional group. Let's for example say alkene is a functional group that is called double bond. So in this case, these two molecules have same molecular formula, same number of carbon, same number of hydrogens, but they are isomers because of the position of double bond is different in these two molecules. Have a look at the first one. The double bond is at the start. That's called terminal alkene. Have a look on the second example. The double bond is in the middle. That's called internal alkene. So the position of the double bond is different. Here the double bond is present at number 1 position. In this case the double bond is present at number 2 position. So this is how position isomerism exists in these two compounds, and this is how we define positional isomerism, in which functional groups, in which compounds differ in the position of a functional group. Alright, now let's discuss the structural isomerism's third type, that is functional isomerism, in which molecules have same molecular formula like C2H5OH, but the functional group is different due to the change in functional group. Here the functional group was same, but the position of functional group was different. Here the functional group is different. In number 1 the functional group is alcohol, in number 2 the functional group is ether or dimethyl ether. So to be precise, the functional group isomerism arises due to the presence of different functional groups. Interestingly, these two compounds contain different functional groups, but they have the same molecular formula C2H5OH. They are isomers because of change in their functional groups. Number 4th type is metamerism. So people often confuse metamerism with functional group isomerism or positional isomerism. Here I agree that position of the oxygen or ether is different than this one, but the chain length is same. If you see 1, 2, 3, 4 carbons here, 1, 2, 3, 4 carbons here, one oxygen here, one oxygen here. So the number of carbon and number of hydrogen and number of oxygen are same in these two molecules, but the chain length is different. So metamerism arises due to the difference in the chain length of a functional group. And the fifth type of structural isomerism is tautomerism, and the compounds that exist in tautomerism are called tautomers. The most commonly studied form of tautomerism is keto-enol tautomerism. Keto because of the presence of ketone functional group, and enol because of the presence of ene and ol. Ene means double bond, ol means alcohol. So these are also the type of structural isomerism. They differ just by changing the position of a proton. Have a look at this compound. There are 6 protons total. Here, have a look at this compound. There are 6 protons. 6 protons means hydrogens. And there's a change. One proton goes to this oxygen, makes it OH, and this double bond shifts on this one, and this is called ene. So let's revise again. There are 5 types of structural isomerism: chain isomerism, positional isomerism, functional isomerism, metamerism, and tautomerism. Let's go further deep into the type of isomerism, that's stereoisomerism. Stereoisomerism is further divided into 3 classes or types, that is optical stereoisomerism, confirmational stereoisomerism, and geometrical stereoisomerism. So geometrical stereoisomerism exists in double bond alkenes like cis and trans, where 2 groups across the double bond have same or different arrangement. If they are opposite to each other, we call them trans, like see this methyl and this fluorine are opposite to one another, that is trans or E. But there is a subtle difference between E, Z and cis and trans. I will describe in another video. That video will exclusively about geometrical isomerism, and I will make another video exclusively about optical isomerism. In this video, I'm just introducing what is isomerism, what are the different types of isomerism, and just defining with one example. So E is not always trans, Z is not always cis, remember this. But in simple words, yes, you can say E is trans, Z is cis, but I will make another video in which I will give detailed explanation about geometrical isomerism, and you will learn about it. So again, let me define. Trans is that in which 2 groups across double bond have opposite arrangement, that is trans or E. Cis is that in which 2 groups across double bond have same orientation, same side, they are on the same side, that's why we call it cis or Z. And another type of geometrical isomerism is syn or anti. This also occurs in carbon double bond nitrogen. So if you see methyl and hydroxy group are on the same side, this is called a syn arrangement. In this case, methyl and hydroxy group are on opposite side, that's called anti-arrangement. And the conformational stereoisomerism exists in single bond compounds, and they can adopt different conformations: gauge conformation, anti or syn. I will make another video exclusively on conformation. I'm just introducing here. And the third type of stereoisomerism is optical isomerism, and it is further divided into number of types like enantiomers. They are non-superimposable mirror images. So the enantiomerism exists in chiral compounds. Stereoisomerism type optical isomerism exists in chiral compounds. What are chiral compounds? Those compounds which contains a chiral center. What is chiral center? Chiral center is a center which contains 4 different groups attached. Like if you look at this carbon, there are 4 different groups: hydrogen, hydroxy, methyl, and acid. Have a look at this. This is the enantiomer of this compound. So we will discuss enantiomers, diastereomers, meso in another lecture, but just I am saying enantiomerism is a type of optical stereoisomerism. Meso compounds also exist. Meso stereoisomerism or meso optical stereoisomerism exist in those compounds which contain plane of symmetry, so we can cut the molecule on the middle and see that both the sides of the molecule become equally similar, identical. And this exists in chiral compounds again. And next type is diastereomerism. Let's have a look at the glucose example. The diastereomers exist because of the configuration is changed at only one chiral center. If you see, the configuration here is on the bold line, and in another diastereomeric form the configuration is different on that chiral center. but remain same on all the chiral centers. One or two, but not on all chiral centers. So about in diastereomers, enantiomers, meso compounds, I will make a separate video, and I'm just introducing these are the types of stereo-optical isomerism. Okay, we have described all types of isomerism, structural and stereo, 5 types of structural, 3 types of stereo. Now let's have a look on this very useful chart. So you see a molecular formula for any compound. If the answer is no, that means they are non-isomer. Means if they don't have the same molecular formula, they will be non-isomers. If they have the same molecular formula, then there exists isomerism. If the molecular formula of two compound is not same, then there cannot be the isomerism. Okay, so this is no, means two compounds do not have the same molecular formula, end of the story. But if two molecules have same molecular formula, then the story goes around. That becomes isomers. Now we need to look for the connectivity between those two molecules which have same molecular formula. If those two molecules have same molecular formula, they are called isomers. But if they do not have any connectivity, they are called constitutional isomers. Like structural isomerism is also called constitutional isomerism because they do not have any connectivity like double bond or chirality or something. If they have connectivity, then this gives rise into stereoisomerism. What is stereoisomerism? Because of the presence of a stereo center or a chiral center. Now again, if compounds have same molecular formula, they will be isomers. If they do not have any connectivity, they will be constitutional isomers. If they have connectivity, they will be stereoisomers. If the stereoisomers are superimposable mirror images, that's what called enantiomers. If they are superimposable mirror images, that's called diastereomers. So you need to follow through this chart in order to recognize what kind of isomer it is. So it's a yes no chart. You like a flow it from starting. You begin with if the two compounds have same molecular formula, alright, then they are going to be isomers. If the two compounds they don't have the same molecular formula, no way, they can't be isomers. Alright, then again you need to look for connectivity. If the connectivity they don't have any connectivity, that's called structural isomerism or constitutional. If they have some sort of connectivity, that's called stereoisomerism. And again, stereoisomerism is further divided into enantiomers and diastereomers. I hope I have clarified the isomerism concept, including its types with examples. If it is still unclear to you guys, please put the comments below in this video and I will try to answer your questions. Please subscribe this channel and share it with your friends if you want to learn organic chemistry and master it. Thank you. See you. Bye.